Thank you very much. They said I could speak about whatever I want, so I thought I'd speak about libraries and makerspaces. I hope that's all right. But I want to start off by introducing myself in the context of this presentation, because I was especially delighted to be asked to give this presentation because from an early age I had what you could call, I don't think it would be going too far to call, a love affair with the library. We spent as much time as possible together. At school, I spent pretty much every lunch hour of every day reading in the library. Yep, I was that kid, a total nerd. Everything from the Asterix and Tintin comics to the complete collection of Isaac Asimov's Robot novels to all the reference material, scouring the encyclopedias and the chemistry textbooks for pyrotechnic reactions that I could use in making my own fireworks, which in SA at the time you could not buy. Now, at the same time, we were lucky enough at my school to have a metal workshop, which I guess is less common these days. And so in shop class, we made a sheet metal toolbox and a tool steel punch. And I was pretty amazed when I went to Google Images and looked for images of those that very similar plans, which even say year 9 on them, are online. And I couldn't get enough of this in school. So I would stay after school, and I negotiated being able to use the metal shop after school, and I would make things in the metal shop. So it was kind of a makerspace before the term was coined. And yep, I was definitely that kid, right? The complete geek. So for example, I made a larger toolbox to keep all my pyrotechnic chemicals in. Later on, I accidentally burnt a huge hole in the bottom of it with nitric acid. I digress. Anyway, remember, this is all pre-internet, right? So my friends and I had no access to pyrotechnic literature in general. So some of the compositions we independently developed, we later discovered were responsible for the majority of fatal accidents in the pyrotechnics industry. So, whoa, right? So you can imagine my thrill when I got access to the fabled Bar Smith Library at Adelaide University. And I still remember the very first book that I checked out of their reserve collection, Military and Civilian Pyrotechnics by Ellern. So at last, I had access to real information, not least of which was safe compositions and practices. So the library was just the best thing ever. But like any relationship, the library and I had our torrid ups and downs. This time now was the mid-90s, and there was a new cute young thing in town that caught my eye. I think you know who I'm talking about, the internet. Now again, early days, pre-web. Knowledge transfer was still mostly peer-to-peer. So if you wanted to know things, you went to mailing lists and Usenet news groups. You had to actually ask questions, and you had to listen to other people's conversations to find things out. So the internet was less of a library and more of a community center. But that was all to change pretty soon too. Late 90s, the web came along, and with it the first search engines as we know them now. Alta Vista from Digital was the first to make the stunning, at the time, discovery that you could index the entire web. And then the young upstart, Google from Stanford University, a couple of years later. With the web, the internet had become a library. So, those Asterix and Tintin comics I mentioned, I went and read them all again recently, but they were just a click away. They're out of copyright now, I think, and you can just go on the web and get them, scan PDFs. At any rate, I left Australia around that time, and I went to MIT. And MIT has amazing libraries. One of them is inside this main dome, Building 10 at MIT. But a funny thing happened. I didn't really go to the libraries anymore. I used to go to the reserve collection right at the end of the day and borrow the textbooks for my classes because you could borrow from the reserve. There was a 15-minute time limit on the reserve collection unless you borrowed them at the end of the day and then dropped them off before it opened again in the Dropbox in the morning. So I would borrow the textbooks, do all my problem sets, and throw them back in the morning. So other than that, pretty much the only time I'd go in the library was in the dead of night, right before things would mysteriously appear on the outside of the building. That's R2-D2 there. So, what had happened to our relationship? The internet had changed everything. But I did spend a lot of my time somewhere else. I was at the Media Lab, and down in the dingy basement of the Media Lab, even sort of like the basement of the Edge, but much dingier, was the prototypical Fab Lab. So that's where Neil Gershenfeld developed the concept that became the Fab Labs that spread around the world. And there are all kinds of amazing machines down there, the laser cutter, water jet, 3D printers, This is early powder Z-Corp printer, CNC routers and things like that. And as the library had done earlier in my life, this place completely changed my life. Now, interestingly, now that I've graduated, I go to the MIT libraries quite a bit, but not to access content for myself. When I was a student, I was the editor of Voodoo, which is MIT's humor magazine, and it's got a remarkable history dating back to 1918. And I decided to scan in that entire history and make it available on the web, which is a process that's ongoing. We're still doing this. There's a lot to be done. So I go there to access the historical archives and to digitize things to get them out of the library. So it's kind of this reverse library process. So both the libraries and makerspace type places have been crucial, life-changing places for me. And I'm not, maybe I'm not your typical example of a library user. But I wanted to tell you my story so that I can try and frame the changes the libraries are going through in the context of that experience. You can see where I'm coming from. And of course, you guys are on the front lines. You know those changes much better than I do because you're having to deal with them. So I was thinking, preparing this talk, like, what can I tell you guys that's really going to be useful to you? Because I think even though there's upheaval in this space, with that upheaval comes a lot of opportunity. So first off, I wanted to look at why libraries and makerspaces are intersecting, in my opinion. Other than that, if that library-makerspace combination had been around when I was a kid, you would have had to physically drag me out of there every night. And also, what is a makerspace or a hackerspace? In the late 80s, there was a sociologist called Ray Oldenburg who described a concept of a third place, which was different from the main two places that people spent all their time. Wow, what happened there? Thanks, VPN. The two main places, people's homes and their workplaces. The third place was a space where people could congregate and interact on their own terms. So if you look up the Wikipedia article on third place, they give an example in Brazil of the barbershop, right? That's a place where people, mostly men, hang out, talk, swap ideas and gossip and everything, in addition to the kind of fundamental nature of getting their hair cut. In our society, maybe the coffee shop or something like that's a better example. But Oldenburg gave 8 examples of a third place. It's neutral ground, so no one's there because they have to be there. It's a leveler. Everyone there has the same status. Conversation is one of the principal activities. It's accessible and accommodating, so it's easy to get into. You don't have to pass any tests, and people feel welcome. There are regulars there, frequent attendees that set the mood and the tone of the place. It's low profile. It's not extravagant or snobby or pretentious. There's a playful mood. And it's a home away from home. People feel like they have ownership of the space and a sense of belonging. And I think when you look through those criteria, the library seems applicable, and it's certainly the case with the makerspaces. So because I'm a nerd, I like to arrange things into groups. So here's a kind of taxonomy of the kind of makerspaces, at least that we have in the United States. And I'm arranging them left to right, loosely from least to most commercial. So on the left-hand side, all the way at the very non-commercial end, are the shared workshops. And the example I'm using here is MITRES, the MIT Electronic Research Society. So that's a place that's just a complete chaos of stuff that people have brought in and they work on things. And I call it the school club model of makerspace. So the funding doesn't really come from anywhere. There's really kind of no funding for this kind of place. It's just stuff that people can scavenge, or the university gives the space. So it's kind of the funding, in as much as there is funding, comes from the upper organization somewhere, and the principal activity that happens there is ad hoc projects. People just come to do whatever. Then we have things like the Fab Labs, which you heard about earlier today, such as Fab Lab Adelaide. And I call this the community center model. The funding comes from public funds and from classes that you pay to do. And the principal activity of the lab is open access to the equipment for any purpose. One of the rules of the Fab Lab tenet is you cannot charge people for access to the lab. You can charge them materials, you can charge them for courses, but it's open, free access. Then you have the hackerspaces, and I'm really pleased to note that there are quite a few of these cropping up in Australia now. The ones that I'm going to use as an example here are the ones in the Denver, Colorado area, DenHack and Tinkermill. And I call these the lodge model, by which I mean a Masonic lodge or a fraternity kind of model. So it's funded through a loose collection of membership dues that you pay to be part of the organization and donations. So not everyone's paying the same amount. And the principal activity there is social, bonding over shared projects and shared education. Then an offshoot of these in many cases, the DIY storefronts. So for example, the Concoctory, which one of the main DenHack people founded as a storefront for makers. You can see them from that photo. The creativity shop is its tagline. So I call that the pub or coffee shop model. So the funding comes from the sales of the shop, equipment and supplies, and the main activity is driving those sales with attractions like classes. So for example, as a pub might offer free live music, or a coffee shop might offer free poetry readings, a shop like the Concoctory offers free classes to get you to learn how to use these things that you will then buy. And then all the way over here on the more commercial side, the machine tool clubs. So some examples are Tech Shop in the United States, that's kind of a franchise model, or in Boston, the Artisans Asylum. And I liken these to the YMCA or a gym model. So the funding comes from strict membership dues. You pay to be a part of that and use the equipment, and you pay to take classes. And the principal activity is equipment for hire for your personal projects. Now, I think library makerspaces come closest to the Fab Lab model. The funding is public, the classes are offered, and so on. But public libraries are kind of absent from this taxonomy on purpose, because I think that they're kind of playing catch-up in the space. Many of these models that you see here are filling a niche both on campus and in the public sphere that libraries could have filled but haven't. So the hackerspaces in particular, even though the idea of a hackerspace is not new, they've been around for quite a long time, this modern incarnation where they're really proliferating tracks some of these other factors that maybe have started taking people, at least maybe people like me, out of the library because they can get information on the internet. So what can you expect to find at makerspaces? Most of them have some collection of these general tools. Small computer-controlled equipment, CNC stands for computer numerically controlled. So your 3D printers, laser cutters, shop bots, and so on. Your basic shop tools, the things you'd find in a shed if you're lucky enough to have a shed, a drill press, belt sander, that kind of thing. Hand tools, power tools, screwdrivers, that kind of stuff. They tend to be big on electronics because that's an area where people are kind of really thirsty to learn about things. So soldering irons, oscilloscopes, kits. They also tend to cater to the more crafty-oriented people. So you see your sewing machines and things like that, because people are not always interested in the really geeky engineering stuff. And then this is really important. They're sources of components, fasteners, raw materials, and things like that, because a big barrier to entry in making things is having all that stuff that you're going to make stuff out of. Now, the gym-style places at the high end, that's where they have a commercial incentive to go all out on equipment. So they'll have the large machines and the computer-controlled tools, things like your mills and lathes, water jet cutters. And they can afford to do that because these tools require a lot of care and maintenance, but they're charging that subscription model. You also tend to see the woodworking tools more in those places than in the small spaces because woodworking produces a lot of messy, flammable dust. So you have to have, despite the fact that that stuff is pretty low tech, it tends to be at the higher end places. Similarly, hot shop equipment like welding, plasma cutting, and stuff like that, this is not high tech, it's basic stuff, but you need to have permits and so on, and you need to get the fire department to approve it. And then down the other end, the hackerspaces, they tend to have unpredictable things. For example, the Tinkermill has a kiln, and they do all kinds of weird things in that. Hackerspaces are founded by hackers, so you find random retro computing hardware and weird things that have been scrounged or built by the members. So that sort of unpredictability can be good, but it also can make the place cluttered and distracting. So you need to sort of be aware of that balance. To give you an idea what happens at these hackerspaces there in the middle, I'm on the mailing list for DenHack and Tinkermill, so I scraped their schedules for the last few months. At Den Hack, you might do 3D printing introductions, printed circuit board fabrication classes. Every week they have a dojo in coding and in science for the kids, so basically classes in coding and science. A Raspberry Pi day. A Raspberry Pi is a little desktop computer on a board that'll fit in a pack of mints, and you can do anything you can do with a regular desktop computer on it, as well as talk to robotic hardware. Ham radio setup day. Of course, they're hackers, so they have lockpicking for sport. That's a big thing at the hackerspaces. They have a streaming radio station. Every so often, they might have a fire night with thermite or things that are powered from propane. And then your more social activities, game nights. Work from Den Hack Day once a month. So people who work from home are encouraged to come in and work at the hackerspace so that there's people around there and people are going to hang out and be social. Over at the Tinker Mill. Now, Tinker Mill's in Longmont, Colorado, so that's about 45 minutes drive away. So not very far for a place to be able to support two of these major hackerspaces. Home automation. Workshops for kids who are doing the robotics competitions, like First Robotics. Basics of the laser cutter and CNC router. Game development forum. Library Teens After Dark tour, taking teens from the public library and bringing them to the hackerspace and giving them a tour of what's available at the hackerspace. Drones, beer brewing, how to prep your car to paint it, understanding the internet. So not only do they have the community numbers to support these efforts, when you look at that list, it doesn't support some of the scary preconceptions people might have in the media about hackers. These look like pretty significant additions to the educational landscape. So here's some kind of just basic things about doing a hackerspace that, from my experience, could be useful. Number one, it's really all about achieving critical mass, right? So that means people, having enough people you can count on to be there and to do things, organize stuff, as well as that community demand that you can attract. Also, the space itself, a space that's big enough. It can support the activities you want to do. It's close and accessible enough, because people are going to make that decision, oh, do I stay at home and work on my project, or do I go out to the hackerspace? If it's hard to get to, people won't go. And then the critical mass of tools and equipment, so that when you get there, you can actually accomplish things without wasting a lot of time searching for stuff or cobbling things together. And mass attracts mass, just like gravity. So eventually you may need to have a plan to deal with too much demand, right? That sounds like a problem everyone wants to have, but a lot of hackerspaces eventually do encounter that because this stuff is really popular when people have access to it. The library model is that everyone doesn't have to buy their own book, right? It's shared equipment. You buy one book and you share it around. And that's more efficient for everyone. And hackerspaces are all about optimization of that capital equipment. For example, an oscilloscope, like a high-end oscilloscope, might cost $10,000. Unless you're a professional electrical engineer, you're not going to be using it all the time. You can't justify that purchase. But if there's something that's there that everyone can use, then it could be worth it. Once you've got a space, you really have to think carefully about space management. It's more than just laying out the tool spaces and the workspaces and so on. For example, personal storage. If you allow personal storage at the hackerspace, then you lose a lot of space, because now you've got non-shared space that people take up, and people will leave half-built projects there, sometimes for months, and so space gets kind of wasted. If you don't allow personal storage, then people will leave their stuff out everywhere where it gets in everyone's way, or they don't attempt big projects that take a long time to complete. And that's kind of bad. So you want to try and trade that stuff off. Secondly, cruft, which is I guess, North American slang for detritus, accumulates, because people bring along stuff they think might be useful. They don't want to throw things out. It's basically a hoarding problem. So, it's a good problem to have, because it's good to have all this stuff, but if you don't have a management plan in place to organize all that stuff and to keep evolving that organization, it becomes impossible to deal with, and you can't find anything that you need. You've got to take care to avoid the tragedy of the commons. Tragedy of the commons is the fact that shared resources get abused. It's the economic incentive for rational individuals is to make use of stuff, but not to take part in fixing it when it gets broken, for example, because that's everyone's problem. So you really have to manage that closely. And for example, shared workshops, they have to have like a workshop Nazi, right, that really just is on everyone to clean up after themselves, to fix things when they get broken. I know one space where the shop manager sends out an email to everyone who uses the shop if someone leaves a drill bit out of place, and that really is a disincentive for people to leave a mess. We have to talk about safety and liability, right? Like sometimes we want to gloss over that because we know that some people are scared of this and they won't let us do what we want to do if they think it's going to be unsafe, but we have to make sure that our users are safe. So there should be procedures that ensure that users are trained in the correct usage of the tools and that they're disciplined in terms of using the safety equipment as second nature, right? So that means the safety equipment has to be present in good working order. It has to be easier to use it than not to use it. And then you've got to make sure your stuff is properly maintained, that your electrical work is done properly, damaged items are repaired, replaced, and so on. Do your electrical work properly with lockouts so that people can't unplug things or run over cords and damage them. Emergency stop buttons are in the right place. Do that properly because a culture of safety from the beginning is relatively low overhead and minimizes accidents. So, I'm sure a lot of people now are thinking, man, this is too much, right? A library doesn't have this kind of resources or experience to support all these tools and activities and rules, right? This is not our core thing. We're a quiet place for people to read books. But I want to assure you that it does take work, but it's really possible and it's in everyone's best interests. Here's a school I was teaching a studio at in Mumbai, India, a month ago. So this is the lower school library. And I took a quick couple of snapshots. From this angle, it's a totally normal school library. But flip 180 degrees, and there's their makerspace. So it doesn't have to take up a huge footprint. You can see, if you look closely, this is a terrible photo, I apologize, but there's 2 3D printers there in the background. They've got their space organization down, to some level. So they've got their bins of components over here and shelves over there. And then the rest of it is all workspace. And it's not normally that messy. The reason why there's all that stuff in the workspace is those were the bins of our components for the studios that we were running. So the library just seemed to be a natural area for the makerspace, and they embraced that and made it work. And I find that at another school I'm consulting for right now, the administration wants to move our robotics and makerspace into the bibliothèque, they call it, their library as well. So I just mentioned that because it seems like the synergy is good enough that you can get the administration on board. And I know that that's, in any organization, that's a key part of making things happen, is making sure the people at the top understand it and are on board with it. So what are the benefits of bringing making into the libraries? Well, space is a big one. It may sound harsh to say it, but the move to digital content repositories means that libraries are starting to have space that they don't need to store books anymore. And they may need to justify the continued occupancy and cost of that space. The shared capital equipment model, as I mentioned, is right in line with the traditional model of the library. One shared resource, books, being replaced with other shared resources, tools, equipment, materials. And then there's a sort of more contemporary model of the library too, which is providing access to new technologies. So one example is, for years, computer clusters in libraries were the way that, for example, low-income people accessed computing power and the network. But with broadband and with the advent of mobile internet, that's really reduced the need for this kind of new technology access in the library. But there are other new technologies, like 3D printing, that match that more contemporary mission. And I would argue that the future model for the library, as we go forward, is to do in the physical and the offline community space what the web does online, which is to offer a high branching factor, which is a kind of computer science term, meaning that one idea or connection leads to many, and each one of those leads to many, and you get that web structure spreading out. So hacker spaces and maker spaces bring people into contact with these new experiences and new perspectives in the physical world. One effect this has is to enable greater creativity in the learning process, I believe. So learning by doing, I think, is the most effective form of learning, but creativity comes from nonlinear processes. So just giving someone a kit and telling them to follow the instructions doesn't necessarily make them use their creativity and develop it. So at that studio that I was developing, that I was teaching in Mumbai, we were doing little solar-powered vehicles. So it's kind of like those little vibro robots that some of you guys did today, but they were solar-powered and they were wheeled vehicles. And some kids came up and said, we want to do a boat instead. And I was like, all right, let me see what we've got. And I went to their makerspace and I started scavenging around and I found some little high-speed motors and propellers and I was like, all right, yeah, we can do this, like do some boats. So having those resources around to pick through enabled me to say yes, rather than limiting what they could do with the activity. And then finally, the traditional notion of a library as a book repository is, in a way, open source, right? Open source information. And that meshes well, I think, with the modern open source movement, which is at the heart of the maker movement. The term open source itself really comes from the world of computer code, which I'll talk some more about shortly. But I want to talk a little bit about open source in the maker community. Earlier today, you guys saw some 3D printer demos. I'm not going to say a lot about 3D printing today, but I want to talk about where this current explosion in 3D printing came from. Like, why now, right? 3D printing as a technology is almost 30 years old. The excitement now is because of the open source and the makerspace movement that decided to make printers that you could build yourself. So every printer that's affordable today owes its existence to these two makerspace projects, Fab at Home and RepRap, which I know someone mentioned before. Fab at Home was just a way that someone could use the plans to make their own printer, to print with anything that could be squirted out of a syringe. RepRap, the idea was to build a printer that if you had one, you could print the pieces to give one to someone else to make their own printer, and then they could print the pieces to give someone else a printer. So it was kind of this organic self-replication. And the printers that you guys saw today are all what's called fused deposition modeling, printing by squirting out melted plastic. But the homebrew open source community are doing all kinds of crazy homebrew 3D printers. So for example, the Candy Fab that prints out of sugar. And you can make these just like crazy edible things. Open source takes on a new poignance, I think, when we look at a project like Robohand. This is what came out of a South African carpenter, lost a bunch of digits on his right hand, and was like, all right, I'm not going to let this get the better of me. So he started doing research, and he saw an animatronic hand made by a special effects guy in the United States, and started corresponding with him and sending like his x-rays and stuff and saying, this is what I need. Can we design a simple replacement that I can make easily that will let me use that hand again? And so they eventually ended up coming up with a CAD model that was 3D printable. So simple, low-cost mechanism. He pulls the string with his good hand to grasp. And then the source geometry has now been published in online repositories. So anyone can make one. And hundreds of people have made them. And what I have on the title here is code is law, right? Because that code, that geometry to make that, has been democratized. It's been put out there for everyone. Everyone can do it. Sure, you've got to have access to the tools to do that, but that seems like a tailor-made opportunity for places like the public libraries to get involved and make those tools accessible. At the Adelaide Mini Maker Fair that they did last year, there was a group on one floor that was volunteer fabricators that were making things for disabled people. So just little gizmos and tools that would make their lives easier. So a person would say, hey, it's hard for me to open a Coke can. Can you make something that holds the Coke can so I can use my one good hand to open it? Something like that. So I was talking to them and I said, these are all handmade things. Do you ever open source your designs so that people could, for example, 3D print them? And they looked at me like I'd grown a second head, and they said, when you say 3D print, do you mean like a photocopier that makes like physical things? And I said, well, you guys just need to take 5 minutes away from your booth and go upstairs because it's going to blow your mind. Libraries seem like they would be a good place for those conversations to happen, for people to mix together and discover these things. It shouldn't have to happen once a year at a fair if you're lucky enough to live in a city that has that fair. Here's another open source example, which is from the art world. There's an artist out there that makes sculptures and open sources some of the designs so people can put their own spin on them. So this is one of her sculptures. Her name's Bathsheba Grossman. This is one that's made out of metal. And then she posts on her website when people make it out of other things. So some guy in France decided to make one out of plywood. I had a laser cutter and wanted to play around with a laser cutter and make a sculpture, so I redesigned it. I kept the intersection geometry, but I redesigned the outside of it to make one that was similar, but more personal for me. So there's like a whole new world in this open source movement of enabling people to share your ideas and put their own stamp on them. So on that note, I did want to talk a lot about, well, not a lot, but more than about 3D printing, about one tool, which is the laser cutter. At the Fab Lab and at many of the hackerspaces, this thing runs non-stop. It's the most popular tool because of how quick and easy and versatile it is. So people make things with laser cut components. For example, this Nautilus, the sort of concentric shell elements were cut out of colored cardstock on the laser cutter. There's like really great software that's coming out now that can slice 3D models into laser cutter suitable parts and so on. You can laminate or screw together things to make 3D assemblies. So, hey, all of these hobby 3D printers, when they first came out, they're all made out of laser cut parts. You can make curves out of flat sheets. This is something that someone made in one of our masterclasses at the Fab Lab Adelaide. You can do all kinds of crazy things. I've got a friend that makes, it's like the king of laser cut mechanisms out of MDF. So he makes all these crazy camera rigs and jigs for making professional music videos. So laser cut gears and assemblies. All of these pieces, apart from the metal pieces, are laser cut. And here he is flying this rig completely illicitly off the roof of his New York apartment block with weather balloons. You can also do fabrics and leather, right? So it's not just for the gearheads. People who are interested in fashion and design can make these, for example, these amazing lace type things. Or you can do labels and stencils. So you can cut sticker material and cut out things and do your spray painting or whatever. Here's a liquid nitrogen-powered backpack-mounted air cannon that I made while I was a student at MIT, and I laser cut all the stencils. And I have to show you one quick video of this because it would be cruel to show you a liquid nitrogen-powered cannon and not show you it firing a beer can at a wall in slow motion. This is from the show Time Warp that I worked on for Discovery. Anyway, digression. So the advantage of the laser cutter, from concept to drawing to layout and output, it's the fastest of all tools. It's really amazing. The footprint is pretty small. You just need exhaust or a toxic off-gas scavenging system. And you can also do, as well as cutting, etching and scoring. So here's a piece from an MIT professor that's actually in the Museum of Modern Art in New York. That's a computational origami piece, elephant hide paper that's been pre-scored with the laser cutter so they could make those folds. And then, of course, you saw earlier from Jake, the laser-etched sausages. However, I have the cooked version. So I think that every makerspace, every library should have a laser cutter. A big part of the open source movement now is the open source hardware movement, open source electronics, and the most famous of these is the Arduino. Jake mentioned this as well. It's a little computer on a support board such that you can plug it into USB on your computer and you can start programming and make it go. And you can wire in inputs like sensors and outputs like LEDs and motors really, really easily. Extra functionality can be added to it in the form of these shields that are daughter boards that snap on to the top of the thing, so you don't have like wires going all over the place. So it's really simple to get started, yet it's very extensible, and it comes in a whole lot of form factors for different applications, including wearable. You can sew these onto your clothing. Now, a lot of people think electronics is this scary thing, right, that's only for engineers. But I've taught 6th graders how to use these. In fact, I've had 6th graders that refuse to look at a computer screen come up and beg me to teach them how to do it and how to program it. And I've taught their teachers as well. And in fact, the teachers were a lot more scared than the 6th graders. But the key to this thing is the simplified tool chain to get up and running, to plug this thing in and not have to install a lot of weird software and do a lot of debugging just to get going. So don't be afraid of it. And all kinds of sensors are available for it, pretty much everything you can think of, from soil moisture sensors to Geiger counters, and they're very inexpensive. But all that wiring and low-level stuff, I know, can be scary. So I was really excited to see this really recently. There's a big manufacturer of educational technology for science in schools called Vernier, and they make these sensors that plug into a capture box that automatically does things like graphing the sensor readings and exporting the data to an Excel spreadsheet, whatever. Science class stuff. Kind of, packaging it and making it easy. And then recently, SparkFun came out with a Vernier shield for the Arduino. So you can take all these Vernier sensors, you can plug them into this shield, and then you can start reading them from the Arduino and doing things based on them. This is a big deal to me because it shows that the big boys, right, these guys are in all the schools, They're willing to play nice with the open source people and make that available. So places that want to, they're scared of like the stuff that's got wires everywhere. They want to invest in these turnkey solutions that are robust, like the vernier equipment. They can use that investment to push beyond basic labs. So schools, for example, but I think also libraries, right? Why wouldn't you lend out some of these sensors and stuff from a library, just like you lend out videos and CD-ROMs and stuff? Think about it this way. This is why I think it's a big deal. Moving from a thermometer like an alcohol thermometer that you read and write down the numbers, to one that automatically makes a graph of the numbers, I don't think that's a quantum leap. But moving from a thermometer to one that you can then program a little computer to do something based on those thermometer readings, I think that's a big deal. That's a new level. Of course, this all requires software support. So there's some really exciting things happening on that front as well. This is some more stuff from many labs. Actually, the guy flying the weather balloons in that photo is the founder of many labs. He's providing processing tools to work with Arduino-based sensor systems that run in a web browser. So even if you've got your Arduino that's got wires all over the place, that crazy octopus of sensors, right? You're measuring all these kinds of things. You can program it, gather that data, process it, visualize it, and share those data sets with other people to process it without ever leaving the web browser. So that kind of thing takes care of a lot of the heavy lifting that otherwise might worry people, for example, in a library who are like, oh my God, like, I don't have the expertise. I don't have a degree in electrical engineering. I can't support this kind of work. Those support structures and tools are out there, and they're available for makerspaces to take advantage of. So on that note of software, I want to get back to what I mentioned earlier about code. Code now makes everything run. There are tens of computers in your car. Everyone's carrying one with them, at least one, in their phone, and so on. The fancy 3D printer that you have, its user interface is run by code. The 3D model slicer is code. The commands that the computer sends to the printer is a form of machine tool code called G-code. But more than any example that I could pull out about code, code's a way of thinking. It's logic, it's structure, it's analysis. I think it's important that people have exposure to code. And in many cases, they're not getting it. I think it's where people are in danger of being left behind in our society now. It's the new literacy. And of course, once you mention the word literacy, you're talking about libraries. The idea of haves and have-nots in the world of code has big implications for libraries, because you can't learn to code by reading about code. The only way to learn code is to do it. So the school I've been working with in the States is called Beaver Country Day School. My official title there is Innovator in Residence, which is really flattering, because actually I'm just doing what I know how to do. But they're the first school in the country to place computer coding in every subject in the curriculum, across the board. Not forcing it in where it doesn't make sense, but making it available in every subject as part of basic literacy. So here in this example, we have French students writing web pages from scratch, raw HTML, to communicate with each other. And I think this makes sense on a couple of levels, right? The whole web runs on HTML, so why shouldn't we scratch the surface a little and see what's going on there? And then also, it's a markup language, so it's teaching them something about language as they're learning a foreign human language. Students in a sculpture class programmed digital artwork and then shared with other students how to create that. So it's got communication and sharing and tools involved, as well as just that process of creation. Here are some examples from the English class, which is marrying poetry and code. And when you think about it, poetry is kind of about coded and indirect language. So it sort of makes sense. And to me, what's surprising about this, on the left, they were rewriting poems in coded form and then having people decipher them. On the right, they would draw using code to create illustrations based on the poem Invictus. What was surprising to us about this initiative is how fast the teachers jumped in. We thought we'd have to really kind of push people into it, and we didn't intend to roll it out to the whole school immediately, but it got away from us. They just wanted to do it. So you might be really surprised how fast things move for you once you start integrating makerspace activities into the libraries. Now, I deliberately chose all arts and humanities examples to kick off that discussion with, but of course, the sciences have plenty of relevance for code. So these are some of the things that the Year 12s did in a project class. And what's interesting about these projects is that they were not required to use Arduinos or CAD modeling or any of that stuff. They were just told they had to design and build something. They wanted to do computation and sensing and use these advanced tools, all things that required code. So they sought it out. And I think that we owe it to people to help them be literate in this area so that they can achieve the aspirations that they want, because they want to make things that have some intelligence to them. But I hope all this talk of code invites some criticism, and we can talk about this in the panel, because is all of this just directed at the nerds like me who don't need it, because they'll figure this stuff out anyway? What about our responsibility to cater to the underserved and non-traditional audiences? And I'll answer that by saying that one of the missions of the library has always been to expose the community to the world's literary treasures, right? The art of the written word, as well as visual art and the recorded media that we've more recently been able to store and capture and share. I think people everywhere have some innate need to appreciate and to create art. And this has always been a huge part of maker culture. It isn't just the engineers doing this. For example, at the Fab Lab, we've always had a lot of artists in our master classes, like jewelry makers and so on. And we've also had a big spectrum of backgrounds and age ranges, so everyone from high school students up to retirees. This stuff has really, really broad appeal. Here's another example of open source art. This is something that I made on the laser cutter. It's a kind of a light box display based on the file that pirates include when they pirate a TV show or a movie. They put a little kind of signature file in it, and when they pirated the first episode of my TV show, I kind of like pirated their pirate thing and made an artwork out of it. But don't take this stuff from me. Ask the people who are making money off this, the people selling the printers. The 3D printer companies have definitely realized how important art is to the culture that's driving their sales. So these shots are from a company that hired a recent art school graduate to be their designer in residence, working on interesting structures and working on new methods such as adding colored dyes to their output from the printer, which is normally just a single color. The fine artists are getting into the game too, pushing the envelope in ways people haven't thought of before. This is an artist who 3D scans and then remixes Mickey Mouse, and has printed the Mickey Mouse remixes out on a printer that's capable of doing full color output. This stuff is a commentary on how Disney remixed pop culture, right? They took all this stuff from fairy tales like Snow White and Cinderella, made all this profit out of it, and yet they continuously slightly update Mickey Mouse so that no one else can do that. For example, Mickey Mouse recently lost his tail. Why is that? So Mickey Mouse is still under copyright, resets the copyright clock. Here's another sort of more codey example from this guy. This is code meets visual art meets physical sculpture. It's called the Venus of Google. He was given this box, and he searched for a lingerie model on Google Images and then wrote some code to mutate the shape of the box until it got close enough by some similarity threshold to the lingerie model photo, and then printed it out as a sculpture. So this is totally new things, right, that no one was doing a short time ago. Where are our new artists going to get the exposure to do that stuff? Hopefully in the libraries. Also, the collaboration aspect of it. So here's an example of the kind of collaboration that the hackerspaces and makerspaces encourage. He was an artist, Adam Lista, who was taking iconic works of art, such as American Gothic, and then re-rendering them 8-bit graphics style with watercolors. And this other guy saw this, and the second guy was someone who had started a makerspace in his school library, and he was like, whoa, this is so cool, this stuff needs to be 3D. So he partnered up and made these 3D printed out of colored sandstone 3D versions of these 8-bit things, and they're selling them online. Here's Superman, classic image, re-rendered in watercolor, re-rendered in 3D printing. And the interesting thing about this is these two guys have never been in the same room. In fact, on their website it says they've never even heard the sound of each other's voice. They've done all their collaboration over the internet. But ultimately, that digital collaboration was made possible by the fact that Isaac set up this makerspace in his school's library and entered that collaborative sphere. Another artistic pursuit that nearly everyone indulges in to some extent these days is photography. because almost everyone has a pretty amazing digital camera in their pocket, just incidentally because they've got a phone. And the camera can do a lot, but it can't really control light. So people who want to take that art of photography to the next level need to work somewhere where they can manipulate the environment. And lighting is tough. So this is the lighting setup for the photographer that takes photos of the Apple products for their advertising, right? So they want to make it look as beautiful and simple as possible, but it's the most complex lighting thing you can imagine. You can't even see what's being photographed. It's really tough and complex. I actually have been working on a project to automate the lighting system of the studio. It's a kind of robotic system, which is run through an iPad. And I think this is a classic example of a resource that should be shared, right? A studio, whether it's automated like this, or whether it's just a traditional studio with a lot of lights and C-stands, they're capital intensive, right? Occasional use, non-professional people are not going to put in that money to do it. So they need somewhere where they can share the resource. So photography, imagery, and media, so critical to our lives now, are things that we should think of when we think of makerspaces and of libraries, not just making physical things. So I want to start to close out now by kind of playing devil's advocate on myself a little bit. You know, what if I don't want to make stuff? There's a lot of stuff out there, right? There's like all this, all this crap that's coming, plastic crap that's going into the landfill. I just don't want to add to it. What's wrong with the old model of the library? It was all about consumption, right? Absorption of the world's information and literature, not production. Isn't that still valuable? Yeah, of course it is. But technology now lets people consume things in new ways, and we need to be supportive of that. Look at the way people use YouTube, right? They don't just sit there and watch whole movies. They swap short clips, and they do mashups and that kind of stuff. It's what the media researcher Henry Jenkins calls a participatory culture. So these new consumption methods and using consumption to share ideas and curate content within a community is also a creative process. We should be aware of that and nurture it. That's part of the mission statement of libraries and makerspaces. We also don't have to let go of this contemporary model of the library as the access point to new technology and old technology for consumption as well as creation, right? Downloading something off the internet, a 3D model, and printing it on a 3D printer and not changing it at all because you just want that thing, arguably that's pure consumption, even though you're kind of making something. Providing access to those technologies and also providing access to old technologies, retro gaming, fixing broken stuff, right? That's consumption in a kind of sustainable consumption way. So these fit in just fine with makerspaces and libraries, I think. And then, of course, providing that third space, the community nexus, is still valuable, even if what the person gets out of it is not pure creative pursuits, right? Even if it's limited to conversation and exposure to other people's new ideas, this kind of social consumption. All of that stuff is valuable. So to bring us all the way back full circle, last slide, back to the reason that I've been going back to the MIT libraries, there's a big movement now among the hackerspaces to build DIY scanning rigs. So people can bring their physical media in, their books, photographs, and so on, and digitize them easily. That's also not strictly creative work. It's transformative, information from one form into another. But in the process, it's a way of mixing that traditional mission of the library, that access to information, with the maker notion of user-generated content. So it's making knowledge available in new ways. And this new direction has been embraced by the public libraries in the United States, such as the Boston Public Library, which have launched this collective initiative called the Digital Public Library of America. So digitizing this massive collection of historical materials, up to and including the things people bring in, personal stuff, personal historical stuff like family photos, boxes of old letters in the attic, and so on. So I think this kind of thing cements that position of the library as a community third place where we share historical and cultural connections. And once again, the hackerspaces are on the same page of that book, even if the book has a slightly different cover. So let's keep working together on this. Thank you.